This is a demonstration of trajectory aggregation. Consider a 300-second time frame during the midday time of day at an isolated movement. Current penetration rates of observable vehicles provide a sparse observation of the traffic pattern, as illustrated by the time-space diagram. However, we can assume that the traffic demand patterns are stationary within the same time of day. Since the traffic signal parameters are fixed within a time of day, each trajectory can be shifted to align on the same cycle according to their arrival time within their respective cycle. The result is an aggregated time-space diagram where all the observed trajectories within a certain time of day are plotted on the same figure. The trajectory's color indicates the number of stops the vehicle took while passing through the intersection, where green represents no stops, orange 1 stop, and red 2 or more stops. Now consider this movement in a corridor with 6 intersections. The aggregated time-space diagram for the northbound movement at each intersection can be stacked on top of each other to create the aggregated time-space diagram for the whole corridor. For visualization purposes, each diagram is repeated over several cycles. The diagrams are temporally aligned across the entire corridor according to their respective intersections offset. The offset is the difference between the start of the cycle and the reference point. Different offset values will change the corridor's coordination. Aggregation can also be applied to the visualization of the raw vehicle trajectory points. The clip on the left contains 10 minutes of vehicle travel from 5 p.m. to 5:10 p.m. on a typical workday. When the traffic network is controlled by a fixed cycle, the trajectory points can be aggregated to the same cycle. The clip on the right shows each trajectory point according to their time in the cycle, which is calculated by taking the remainder of the actual time divided by the cycle length. In the aggregated vehicle trajectory point clip, it is easier to visualize congestion hotspots, coordination efficiency, and the overall traffic state. To understand the aggregated trajectory point visualization, let us compare it to the aggregated time-space diagram. The Adams Road corridor is outlined by the dashed box with signalized intersections at each arrow. Now recall the aggregated time-space diagram for this corridor in the northbound direction. The black line moving across the aggregated time-space diagram indicates the timestamp of the video. Here we note that the northbound movement at this intersection has a red light. The trajectory points approaching this intersection will reflect this as we move forward through the video. As the traffic signal remains red, trajectory points are stopped at this intersection. The traffic signal will turn green, and the trajectory points will start to move as we continue the video.